In this tutorial video, we'll look at two kinds of computational problems. Let's go over the problems conceptually first before we dive into Eclipse. So these are the two computational problems we are trying to solve. Even though we're going to give a specific example, but it's a very general problem to solve. And you want to know how to solve them in a general way. And so let's go over the problems quickly. So the first kind of problem, in both kinds of problem, you are given an array. And the array can be of type integer, can be of type strings, and can be of type Boolean or any type. And you want to determine whether or not, which means your result is going to be a Boolean type. You're going to return either true or false. You're going to either say yes or you're going to say no. Okay. The first kind of problem is as follows. You want to see if all the elements in the array actually satisfy a particular property. For example, given an array of integer, you want to see whether or not all the numbers in the array are positive. Okay, that's the first kind of problem. That's one instance, which we're going to solve together. And the second kind of problem is, since similar, but it's actually quite different. The second kind of problem is, given an array, determine whether or not some element satisfies a property. For example, let's say given an array of an integer, you want to see if some element in the array is actually positive. So let me just let's think about it conceptually very quickly before we go to programming. Okay, to really for the first one, if you want to know if all the elements satisfy a property, let's say if all the elements are positive, you want to make sure you want to go through the array and make sure every element over there is positive, right? As long as there's at least one element in the array that is negative, which we call a witness. As long as you can find a witness that is negative, then you know that you should return false. Otherwise, you return true if all the numbers are positive. Similarly, if you want to solve the second kind of problem, you want to see if some or at least one element in the array that is positive, then you know you should really give true. Otherwise, give false. So that means as long as you can find at least one element in the array that is actually positive, then you're going to say true. Otherwise, if all the elements are negative, then you will say false, right? Okay, so this is very conceptual discussion over here, but we're just going to see how we can solve it, and I'm going to give you eventually 4 versions of the solutions, and some of them worked and some of them does not work. So we want to make sure we understand why the working version works that way, and also why the not working version does not work. Okay, it's really important to tell the difference. Okay, let's now go to, before we go to Eclipse, I want to give you a little bit intuition about the solution we are solving, because it's a very special kind of problem which we haven't solved so far. Okay, let's just have a look at this particular array, let's say. Okay, so now let's see for this one here. So let's say we have an array called NS, standing for numbers. And we simply got 2, 3, -1, 4, and 5. Okay, and now are all the numbers positive? It should be false, because we know that at this particular index, the number -1 is a witness. Okay, I'll just write it down, witness. It is a witness to tell us that not all the numbers are positive. So the result should be just false. Okay, so now let's see how we will solve this. Of course, in a generally speaking, you want to handle an array of any arbitrary size. But let's say we fix the size to be just size 5. So how do we solve this? You may just declare a Boolean variable, which is called all positive. And then I can simply enumerate all the indices of the array, so from 0 up to and including 4. And then I simply say the first number must be strictly larger than 0, and the second number, third, fourth, and fifth. All the numbers are positive. And then, because every number has to be positive, so I'm using a conjunction over here to say the first number, in this case, which is 2, must be greater than 0, and also the second number, which is 3, that should be greater than 0, and the third number over there, which is -1, should be greater than 0, and the fourth number, which is 4, should be greater than 0, and also the fifth number should be greater than 0, which is 5. Okay, let's see what the result is. In this case, 2 larger than 0 for the first one, it will give us true, and the second one, 3 larger than 0 is going to give us true. And but the third one, -1 larger than 0 is going to give us false. And the fourth one, 4 larger than 0 is going to give us true. And the fifth one, 5 larger than 0 is going to give us true. you can see we got true and false actually for each element, right? So now, since we are trying to combine them using conjunction, as we learned before, for conjunction, it will only be true if all the operands are true. In this case, it is not the case, because you can see that over here, we got at least one false, and this is exactly where the witness is. We got at least one element that fails to satisfy the property being positive. So in that case, overall, when we go do conjunction together, we're just going to give us false, which is what we expected. Okay, that's how you solve the problem naively, and also is very, very specific to this particular array. But when we solve it using a loop, we want to solve it generally. Okay, but let's see one more insight into this particular enumeration over here before we try to go into Eclipse. Okay, so now let's think about it this way. Because if we are trying to run a loop over an array, we can only look at one element at a time. That's typically the case. So that means maybe for the first iteration, we can only look at this particular comparison where the loop counter is simply 0. At the second iteration, we will look at this particular comparison with the loop counter value being 1, and etc. Okay, we can only look at one at a time. We want to make sure we always somehow remember. Okay, let me just write it down. We somehow remember. We somehow remember the result, the comparison result from all the previous iterations. So now that means when we are at this point over here, we want to make sure we remember that the first iteration give us true, and also the second iteration give us true. And when we are at this particular iteration over here, we want to make sure we remember the first iteration, second iteration, and especially the third iteration give us different result. We want to make sure it's always remembered. We don't forget. Okay, so a better word to say that would be we want to accumulate. We want to accumulate the result for the comparison. And the way we accumulate is by using a variable. The idea is we declare some variable over here. Let's say it's simply called all positive. Okay, I'll just say all positive over here. The all positive might start with some value over there initially, and then the first comparison over here is going to give us true. And then when we get to the second iteration, rather than simply rewrite it into, rather than just override it into just true, you have to do a little bit logic over there. Okay, that's something I will try to explain to you when we get to the Java code. Okay, and then let me just say up to now. Okay, that's kind of the insight we want to get into. We want to use the variable to accumulate the result, but how do we accumulate? I'm going to show you directly how to accumulate, and then we'll come back to revisit this particular iPad page and to see their actually equivalents. Okay, let's now go to Eclipse, and then we'll see how to code it up. Okay, so let's go to Eclipse. Let's create a new project called Lab 4 for this week, and then we're going to create a new class. Okay, so now under source, say right click and say new Java new class, and then so now this is going to be version 1. Eventually, as I said, I'm going to show you 4 versions. Okay, so now how about we simply say all positive. Okay, and then I'll say v1 standing for version 1. Okay, and then we definitely want to get a main method here. Okay. And then, okay, let's maximize it, and then now let's program it. Okay, the code itself is very simple, but the logic behind is actually quite worth discussing. Okay, so now let's simply recreate this particular array: 2, 3, minus 1, and 4 and 5. Okay, so we got declare an integer array, and then ns is assigned to new. Actually, let's use the array initializer notation since we know what the array should look like. Okay, so let's see, 2, 3. Minus 1, 4, and 5. Okay, that's the array. Okay, of course we might change this array to something else and then rerun the program in order to show that the loop we're gonna write can solve the problem in a general way. Okay, so now let me show you the solution directly, and then we'll discuss it. Okay, the solution is intuitive. You simply just go over the array one element by one element using a standard for loop. Let's say we can say for integer I is I being the loop counter is initialized to be 0, I less than ns.length. Okay, in this case ns.length would just be 5. right? And then I plus plus. Okay, a very standard way of doing things. And now, how do we actually eventually to tell whether the array is actually all positive or not? Okay, so what I would do is I'm gonna, as I said before, I'm gonna declare a Boolean variable over here. Let's simply call all positive, okay, or all p. Okay, I would say Boolean over here, all positive. Okay, all pos. How about that? Okay, let me just put the initial value over here because you should always remember to initialize a variable when you first create it. In this case, I'm gonna explicitly say that it is going to be true. I'll explain why true must be the case rather than false. Remember, for Boolean variable, you can either initialize it to be true or false. But in this case, it must be true, cannot be false. Okay. And then I'm gonna somehow remember what the comparison result is for each iteration by using this variable over here. However, the way I rewrite this variable is a little bit tricky here. Okay, I'll simply say all positive for each iteration is going to be reassigned. Okay, first of all to itself. So that's actually to itself. Basically, let's say I'm in iteration number 3. Let's say I'm currently in iteration number 3. And then when I simply say all positive is going to be reassigned to all pos. So the all pos over here is basically the result accumulated from all the previous iteration number 1 and iteration number 2. Okay, so now we'll see that in a moment. Okay, it's still maybe a little bit abstract to you, but we will try to trace it using a table as well. And then I will say whatever the current value is for all positive, and then I'm going to say using ampersand for conjunction, and then we'll do the comparison over here. Okay, let me put so ns, the array at position I, being the current value for the loop counter and strictly larger than 0. Okay, that's what I will do. So now if, okay, try to make sure you can actually parse this particular expression, this assignment properly. We're trying to say all positive, the variable is going to be reassigned to this particular right-hand side expression over here, and then the expression itself is a conjunction. The left-hand side is simply the current value for all pos over here, and the right-hand side is simply a comparison to see if the current element we're looking at is strictly positive. Okay, and now let's see if that will tell us the truth. Okay, so now what we can do is I'll simply say system.out.println. Okay, I'll say all elements in array are positive. Okay, I want to know if whether that's true or false. All pos. Okay, I can also change the array to something else. I'll show you. But we're gonna focus on this particular example. Okay, so now what I would do is I'll right click on all positive version 1 and then say run as Java application. What you will see is all elements in array are positive, which is simply false, simply because, for example, you can see -2 is a witness to tell us the property is violated. Okay? To really make sure it works temporarily, I'm going to just, for example, you can try this as well. Simply put this first the array initializer to be in comments, and then I can simply do another one. Let's say 2, 3, 23, and then 4 and 5. So in this case, you can see all the numbers are positive. In which case, what do we expect to see? We expect to see true. Okay. So now if I rerun the program, I'm going to see all elements in the array are positive, and then we have true. Okay, the program seems to work. Good. So now let me just go back to this particular guy here that we got initially. I'm going to focus on this one to do the tracing. Okay, so let me just change this middle number over here because I want to be consistent with how we visualized before. So this middle number should be -1, but the result should still be false. Okay, and the logic would just be the same. Okay, let me just change that to be for consistency to -1 over here. And then let me, as usual, let me copy the code over here, only the part about initializing the array and also using the loop to go over the array. And then let's now switch to iPad. I will revisit this particular conceptual illustration to revisit. Okay, I'll come back here after we do the tracing using a table. So let me switch to this page over here. So now we talk about version 1. Eventually, we're going to see 4 different versions. Okay, let me just paste the code I just copied from Eclipse. Okay, let me paste that. Okay, that's the code we just develop together. Okay, notice one thing here. So you can see that, let's just trace one by one, and then we'll see all the details. Okay, line number 1, you can see that we are simply creating the array called ns. So visually speaking, we have an array ns, which is pointing to the beginning address of some array. And then we got 2, 3, minus 1, 4, and 5. So 2, 3, minus 1, 4, and 5. Okay, so now one thing to note. At the moment, if you query about ns.length, it is going to give you 5, simply because the maximum index over here is simply 4. So 4 plus 1 will give you 5. Okay, remember the maximum index plus 1 will give you the length of the array. Okay, let's go to line number 2 over here. So line number 2, we're simply declaring a Boolean variable over here called allPos, standing for all positive. So allPos over here is simply initial value being true. So we simply say true over here. Okay, and then we'll see very soon why initializing this Boolean variable to be true is necessary. If you initialize that to be false instead, everything is not going to work. Okay, and then we're going to trace the loop right now. Okay, for the first iteration, we're simply going to go to the header of the for loop, and then as usual, we're going to initialize the loop counter to be simply 0. And then don't forget ns.length in this case is just going to be 5. So we're evaluating 0 less than 5, which is going to be true. So that means we're going to evaluate this particular line over here. So what are we evaluating? Let's be very precise over here. So that means all positive is reassigned to its current value. What's its current value? Which is the current value is simply true, which we just did in the initialization in the previous line. Okay, it's simply just going to be its current value, which is true, ampersand conjunction with ns at position I, which is 0, larger than 0. And we know that ns at position 0 is simply just 2. So 2 larger than 0 is going to give us true. Okay, right? Over here it is simply true. True and true is going to give us true. So that means all positive will just be reassigned to just true. Okay, you can think about reassignment even though it's reassigned to the same value, which is true. Okay, so this is just the first iteration. Okay, and don't forget this ns at position 0 is simply just true. Okay, let's do the second iteration, and then once we go to the third iteration, you'll see why. This is actually remembering the result. Okay, so now let's maybe try blue over here. So now when we reach the second iteration, that means by the end of the first iteration, we have to increment I by 1. So from 0 to 1. So now we try to evaluate this particular header, the state condition for the second time. So 1 less than 5 is simply just going to be true. That means we're going to evaluate this same line over here. So let's see exactly how this will look like. So we simply get all positive is assigned to, what's the current value for all positive? Well, it's simply just true. So we'll simply get true over here, ampersand, and then we got ns at ns1 over here, right? Because it's always the I value. In this case, I value is simply just 1, larger than 0. ns1 is simply 3. So that means this guy here is 3. 3 larger than 0 is going to give us true over here. Okay, so true and true is going to, so this guy, this expression over here is true and true will give us true. So we reassign that to be just true. Okay, yeah, so far it's very straightforward, and we haven't really reached the witness just yet that actually violates the property. Okay, so now let's go on. Okay, let me just go for another one. So now we're going to at the end of the second iteration, we're going to execute I++ again. So that means from 1 to 2. Okay, and then we're simply just going to see the following. We're going to see that over here, when we evaluate the state condition over here, I less than ns.length, so 2 less than 5 is going to give us true. Okay. Yeah, so if this is actually true, that means we have to evaluate this particular body of the loop for the third time. So now let me just make some space for us. So let me just move this, and its length is 5 over here. And then, so this is for the first iteration over here. Let me just move that a little bit up over here. So that'll be the first iteration. Okay, this part here. So here I simply don't need it. Okay, and then I will move this second iteration up a little bit so we can have space for the third iteration. Okay, so that's what we'll do. Okay, for the third iteration, so what do we evaluate over here? So we're going to evaluate the same line of code, but now the loop counter I will just be 2. So what we have is all positive is reassigned to. Now, what's the current value for all positive? It's simply just true. So it will be true over here, right? That's the current value for all positive. Conjunction, and then we got ns at position. The loop counter is currently 2, and then larger than 0. ns2 is actually -1. So now here comes the critical point. So -1 larger than 0 is going to give us false. So this guy here is false. And then true and false is going to give us false. So that means we have to reassign all positive to be false. Okay, that's a very critical to realize. And then we're going to rewrite this, reassign this to be false. Okay, up to this point, you can see that between each iteration, we always use the value for all positive, which somehow accumulates the fact about whether all the numbers we have seen so far are actually positive. So now, this is the very first time that you can see this expression over here. This is the very first time it becomes false. Okay, you can see all the previous result is simply just true. And we want to make sure this particular false result is actually remembered. It's somehow accumulated using conjunction. Okay, let's see exactly how that's going to happen. You will see that in the next iteration. We want to make sure this false is going to be propagated until the end. Let's see. So now let's use another one. Let's use maybe green over here. Okay, so now let's say we are going to, at the end of the third iteration, we're going to increment the value for I by 1. So that means it's going to go from 2 to 3. Okay, and then we're going to evaluate the state condition over here for the fourth time. So that means we got 3 less than the length of the array is 5, which is true. That means we're going to evaluate the body of the loop for the fourth time. So what do we have to evaluate? Let's put it down. So we got all positive is reassigned to. So what's the current value for all positive? It's actually now false, right? So it's going to be false over here, n%. So now, what about the current value for the store elements at the index I? So now at index I, it should be index 3. So that'd be ns at position 3 is larger than 0. Position 3 is storing 4. So 4 larger than 0 is going to give us true, right? It's going to give us true. So now, does it really matter that this particular element we are looking at, which is 4, is actually positive again? Somehow it does not matter anymore because we already know for the previous iteration, we already set, based on the comparison of the previous element, which is at position 2, we know that it's already -1. So -1 already gave us false to all positive. So now, conjunction over here doesn't really matter what the right-hand side is if the left-hand side is already false. So that means this calculation over here is just going to give us false. So that means all positive will just be rewritten to false. You can see even though the current element we are looking at is actually positive, but overall it is still going to be false. Okay, that's something you want to pay attention to. Okay, so now let's run the last iteration. Okay, so now at the end of the fourth iteration, we're going to increment the value for I by another one. Okay, so now we're going to execute this particular line for the at the end of the fourth iteration. So now from 3 to 4. Okay, so now if you see that 4 less than 5 is still true. Okay, that means we're still going to execute the body of the loop for the 5th time. Okay, so now how would that look like? So now let me write it down at the bottom here. So that would be all positive over here is reassigned to its current value over here, and we know very well the current value is simply just false, right? Let me put false over here. n%, and now we are going to actually do NSI larger than 0. NSI, I is simply just 4. So NS at position 4 is larger than 0. NS4 is simply 5 over here. 5 larger than 0 is going to give you true. You can see, even though this is a second number that we see is actually right? You can see after the -1, we see one positive number, we see another positive number. But it doesn't matter anymore, because since we have already seen a witness that actually violates the property, so that means it's not possible anymore that all the numbers are positive. As soon as we see the very first witness for violation, it doesn't matter what the numbers are afterwards, because the accumulation for the conjunction will make sure as soon as you get a all positive being false, it's not going to be true anymore once you try to accumulate, right? Let's try one more time. So now false and true is simply just going to give you false. So that means all positive will be reassigned to just false. Okay, so that means simply reassigned to false. Okay, of course, after this, by the way, this is still true, right? So after this, we're simply going to increment the value of I into 5. In that case, 5 less than 5 is just going to give us false, which means we exit from the loop. Okay, you can see this detailed tracing here. The main point, let me summarize very quickly, because once we understand this, we can revisit the previous conceptual visualization and we can make a mini conclusion for this particular solution here. Okay. So what we can see is this. So I want to see, let me just want to do some highlighting. Okay. So now what I want to show you is, first of all, you can see that we have, for each iteration, we're simply doing some comparison over here, depending on what the loop counter value is, right? You can see in the different iteration. Okay, the ones I'm highlighting, right? You can see I'm highlighting exactly 1, 2, 3, 4, 5 comparison. And the loop counter value is just going to be 0, 1, 2, 3, and 4. Okay, that's one thing to note. And now, what's more? You can see that whenever I'm trying to, let's see exactly how things are accumulated. Okay, initially, the value for all positive is simply just true. Over here, right? So now, let's see exactly how things are accumulated. So now, once I got, you can see from the first iteration, we say that the overall result for all positive should be true. And then the true is reused over here in the second iteration over here, because we simply say what's the current value for all positive, right? And then it's simply reused over here. And then for the second iteration, we are going to calculate that the overall result for all positive is simply just going to be true. And then it's going to be reused again in the third iteration over here, when we try to use the current value for all positive. And now, once we calculate that, from the third iteration, all positive is simply reassigned to false. And the false is simply going to be reused over here, right? So this is a critical point when we try to use the current value for all positive again. So this is why we said it's being accumulated, it's being remembered. And then after this, we're simply going to calculate what the result is. So now from the fourth iteration, we'll simply calculate all positive is simply just false, right? And then the false over here, again, is going to be used over here in the fifth iteration, in which case all positive is already false, right? And then eventually we also get false. Okay, you just see that the all positive value is simply reused between iterations. That's how the remembering or the accumulation is happening. Okay, so it's getting hopefully you're getting the logic over here. Even though it's a simple example, only 4 lines of code, but the logic over here is really worth understanding. Okay, let me just move on to the previous page over here. Then let's see how exactly we can link the Java code to this. So now we are revisiting this particular conceptual visualization we just did previously. So now let me get right to the points. So now we remember we actually set the, let me use a different color here. Remember we set the initial value for all positive to be true. Okay, so now that means when we are trying to evaluate this particular expression, think about this this particular long conjunction over here corresponds to exactly the 5 iteration we are trying to do. Let me try to do a little bit demonstration to you. In the very first iteration, we simply say the initial value for all positive is going to be conjoined with the first element in the array over here, right? And that one is going to be true and true. It's going to give us true. So now the true over here is simply just going to be the latest value for all positive, right? And then in the second iteration, we are simply going to do true and the second elements comparison over here. And this one, we know that is simply just true. So true and true is simply going to give us just true. Okay, so far so good. Okay, and then what about the third iteration? Let me use a different color here. What about let's say red over here? The third iteration, so the current value for all positive is simply just true, and we are trying to do conjunction with. So now the third elements in the array, and we know that it's going to give us false because at position 2 is simply -1. Okay, so now we got true and false, which is going to give us false. So that means overall we actually get false. So that is the latest value for all positive. It's getting a little bit messy over here, but hopefully the way I'm drawing over here is showing you how the all positive variable is being rewritten or being reassigned between iteration. Okay, so now as soon as the all positive is reassigned to false, so now there's no way for it to get back to true because we are using conjunction. So let's see exactly how. So now in the fourth iteration, we simply get false. Let me use a different color. How about green over here? In the fourth iteration, we got false over here, conjoined with, and now the fourth elements in the array, even though it's actually positive because it alone is going to give us true. But since we're doing conjunction between false and true, it's just going to give us false. So that means overall is simply just going to give us just false. Okay, even though the fourth number is actually positive, even though. Okay, so now finally, let me just use a final color. So what about I simply use pink again. Okay, finally, so now in the fifth iteration, we're considering this particular number here. So now the latest value for all positive is simply false. And then conjoined with, and now the fifth number is simply just 5 larger than 0 will give us true. But now it's not useful because false and anything will simply give you false. So that means overall, false and true is just going to give us just false eventually. So that's the result we'll get. So that's exact, you can see, try to think a little bit more abstractly over here. That's something I would encourage you to do. The way we evaluate this long conjunction expression over here corresponds to exactly how things work in the tracing over here. Try to really convince yourself that's really the case. That will really let you understand fully how why we are writing the code this way. Okay, one more thing to mention. Okay, two more things to mention actually. Okay, number one, I want you to think about what if we actually change the initial value over here to be false. Okay, so what I meant to do is let me just add a new page below over here. Okay, and then let me also copy the same fragment of code again, and then let me go there. Okay, over here, what I want to ask you is this. Let's say I simply modify the code in the following way. So rather than having the initial value being true, what if I simply set it to be false? Okay, so now think about whether that will work or not. Okay, the answer is it will not work. But now, can we explain? Can you justify clearly why this false is not going to work? Okay, that's question number one. So now the answer is very easy. So I will just sketch very easily, quickly, given that you already understood very well the tracing over here. If I simply set it to false, so now what happened in the first iteration? In the first iteration, let me also 2, 3 minus 4. Okay, let me also draw the array very quickly. 2, 3 minus 1, and 4 and 5. So we don't actually lose track of the array. Okay, let me put the array over here quickly, and then so we can also look at that side by side. Okay, that's NS. Okay, so let's say that's the array, and then that's the initial value for all positive. Okay, so now let's see exactly how things will work. So now for the very first iteration, we simply get all positive is simply reassigned to all positive, and the first element, which is 2, larger than 0. This is true. Agree? And then this initial value, which we just modify, is simply false to begin with. Now, doesn't matter what this is, because that's already false. So false and true is going to give us false. And this is the different behavior than before. Previously, when this is true and conjoined with the true over here, is going to give us true. Okay? And now, let me just change this slightly. So let me just to really show you what the problem is. Let's say 2, 3. Let me even make the array a little bit smaller. Let me say I only got an array of size 2. Okay, only 2 and 3. Okay, now 2 and 3. So now let me simply get rid of this part over here, just to make it easier for you to understand. Let's say I got 2 and 3. What's the expected result from 2 and 3? In this case, no negative number can be found. So that means the result should be true, right? But now, since we set the initial value for all positive to be false, we wouldn't get true eventually. There's no way to get true. So let's, we already see for the first iteration. What about second iteration? For the second iteration, we're going to say all positive is reassigned to, so we're going to execute this for the second time. Is going to be whatever the latest value is for all positive, which we know is simply just false for the previous iteration. Okay? And the reason that we got false for the previous iteration is because the initial value for all positive is set to false. There's no way to really get the conjunction to be true if one of the operands is already false. Okay? So now n%. So now over here, the second element is simply 3. 3 larger than 0, again, it should be true. So you can see true and true. So we should really expect the result to be true. However, since we set the initial value for this all positive to be actually false, so it's going to be useless. It will just be false again. So eventually, we're simply just going to get false as a result. That's wrong. Okay. So now, what's my point for this particular question here? My point is, if you want to do a loop that somehow correspond to a series of conjunction, then the initial value for the Boolean variable must be just true. Otherwise, when you try to accumulate the result using conjunction, if the initial value is simply just false, there's no way that you can ever get another result which is true. No way. Okay, so that's why the initial value should be true. Okay, that's point number 1. And point number 2. Let's talk about a very special case of the input. Okay, and then we'll talk about this, and then we are done for this video. Okay, so now let me simply paste the code over here. That's what we got over here. So now my question for you: is our code going to work if I simply get rid of everything over here? So that simply means I'm getting an empty array. Okay, there are 2 ways for you to write the empty array. You can either say ns, or you can say ns is assigned to new integer array with 0 size. Okay, you can try both. So both are going to give you just an empty array, which means it's an array over there in the memory. It just stores nothing. Okay, just doesn't store anything, just empty. So now my question is, what's going to be the result that our loop is going to return? Okay, so let's think about it. Okay, so now let's try that. So now after this particular line, okay, it's not this array anymore. Okay, let me just wipe it out. Okay, like previously. So ns is simply just going to point to, let me draw it this way. Simply means it's an array that stores nothing. Okay, and more to that, what's ns.length? Well, because it stores nothing, so that means it's simply ns.length will just be 0. Right? That's a very critical thing to remember. Empty array, the length of an empty array is simply 0. So now, when we try to evaluate this particular loop loop header here, I initially will just be 0. Okay? So now, when we evaluate this state condition here, what are we trying to evaluate? 0 less than ns.length will just be 0, which will be false immediately, which means we don't even get a chance to enter the loop for the very first time. So we're just going to bypass this body of the loop completely. And then when we get out of the loop right away, so we say now, we simply say print line, and then we simply say array, all the elements are positive, and then we'll simply print out the value for all positive. What would that be? Well, it would just be whatever initial value we set it to be, will simply just true. Okay, so now the question is, given an empty array, we're saying that all the elements, basically we're saying the following: all elements in an empty array are positive. And we're saying that it simply means it is the case, so it's true. Okay, is this the case? I can tell you that it is the case. Okay, but now I want to explain a little bit of rationale to you. Okay, this is how you can think of it. Why would it be the case that when I have nothing there in the array, why would it be true when I ask the question whether all the elements in the array are positive? Here's how you can think of it. So it would be true simply because you cannot find any witness. So that's why I mentioned this particular word to you. It's more like a mathematical term. Whenever you want to prove that something is not the case, you can always find a witness. Or if you want to prove that something is the case, you can also find a witness. Okay, so there's something I want to get into that's a little bit too mathematical, but let me just mention that in an intuitive way. Because you cannot find any witness that is not positive. I'll give you an example over here. If you look at this particular array, 2 and 3, we know that the result should be true because you cannot find any witness that is not positive. Because 2 is positive, 3 is positive. These are the only elements in the array. You cannot find any other witness that is going to show you that the array contains a negative number. Okay, symmetrically, if we look at this previous example over here, -1 over here would be the witness, because you can find this particular witness that shows you that not all the elements are positive. Okay, so as long as you can find one witness that shows you that the positive property is not satisfied, then you know that the result should be false. If you cannot find such witness, the result should be true. Okay, so this is why. Okay, since you cannot find the particular witness that is not positive, so now you know that the result should be true. Okay, so what's the point for this particular example over here? I'm trying to show you that our choice of the initial value being true is actually correct in two respects. Respect number one, in the case where you simply got an empty array over here, that is going to give you the right result. Okay, you simply because in the empty array, you simply cannot find a witness that actually proves that the property is actually wrong. That's point number one. Point number two, if you choose the initial value to be true, it's going to make sure you can actually properly accumulate the result between from iteration to iteration, as opposed to setting that to false. Okay, so these are the 2 points I really want you to understand. They're subtle, but they're important. Okay, so now for this particular video, we really spent a lot of time discussing this particular version over here. And then in the next videos, we're going to go a little bit faster because we understand the most important logic over here. So we can now see other versions rather much more quickly.